everyone. I'm on page 639 of your book if you want to follow along with me. We're going to go ahead and talk about some three-dimensional shapes today. So the ones that we're going to talk about are something called a prism. Now prisms are three-dimensional shapes that have two parallel bases. And the bases are going to be congruent and they have to be polygons. So they'd have to be a closed-in shape. So we're going to look at two different types of prisms today. We're going to be looking at rectangular prisms. And what that means is the bases are going to be rectangular. Okay, and the two bases, which are the two sides that are parallel to each other, would be congruent. And then we're going to look at triangular prisms, which are the same idea, but the base now is going to be triangular. So again, the bases are going to be parallel to each other and congruent. So as you look right here in this triangular prism, you can see this would be a base right here, and this would be a base right here. When you look at a rectangular prism, this would be this would be a base, and then its base that's parallel to it would be right up there. Okay, so when we look at shapes that are three-dimensional and have two parallel congruent bases, we call those prisms. Okay, so let's talk a little bit about what volume is. So I'm going to jump to page 640 of your book. Let me move my book around here. And let's talk a little bit about what volume is. Now volume, when we look, is basically if I were to take a three-dimensional shape, like this rectangular prism here, how many cubes would it take to fill it up? So we've talked about area being, if I were to tile an area, how many pieces of tile would I need? Well, tiles are two-dimensional. So now we're looking at adding a third dimension, that depth. So now we're looking at how many cubes would it take to fill up. Now the size of the cube changes based off of the measurement. So maybe we're looking at a centimeter cube, so it'd be a 1 centimeter by 1 centimeter by 1 centimeter, or it could be a foot cube, just depends on what the measurement is. So as you look right here, the formula for the volume of any prism is going to be to find the area of the base. So in a rectangular prism, the base shape is a rectangle or square, because remember squares are rectangles. So in this case, we would have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. Okay, so we'd find the area of that base, which is going to give me 36. And then we would multiply that by the height, which right here would be 2. Okay, so you can see that the formula we're using is capital B, and the capital B stands for the area of the base. Okay, and we're going to then multiply that by the height. So in this particular rectangular prism, it would take 6 times 6, so 36 to get the area of the base, and then I'm going to multiply it by 2, the height. It would take 72, let's say they were centimeter cubes to fill this up. So when we label it, we would label it as 72 centimeters cubed. Okay, now that tells me the difference between, perimeter, no, I'm not looking at the distance around the outside. I'm not looking at how many tiles it would take, but this tells me I'm looking at how many cubes it took to fill up that shape. Now if you look, this formula right here, this volume equals the capital B, the big B, times H, can be used to find the volume of any prism. Okay, now rectangular prisms, you probably have heard the formula length times width times height, which works perfectly fine in a rectangular prism. Because if you look at the base, it's the length times the width, so that's the area of the base, and then we times it by our height. Now you'll notice when we get to triangular prisms that it's going to be slightly different because the base is no longer rectangular, so we can't say length times width. Alright, let's look at another one here. Let's jump down to example number 1. Now example number 1, again, we're going to take the formula, the capital B times the H. Now the capital B is the area of the base. It's a rectangular prism, so the base is going to be rectangular. So we're going to do length times width. So that's where we get the 8 times the 6. Okay, that's where you see that from. That's the area of the base. And then the height would be 4. So we take 8 times 6, which is 48, times 4, which would give me 192. And you can see when they labeled it as 192 centimeters cubed. Because again, we're not trying to figure out how long this is. We don't want to know the perimeter. We don't want to know how many tiles it would take to fill it up. But we want to know how many, if I had 1 centimeter by 1 centimeter cubes, how many of those cubes would it take to fill in this rectangular prism? Okay? Alright, so let's jump over and look at a couple examples with triangular prisms. Now, you'll notice with triangular prisms, I'm on 641 if you want to follow along with me. The formula for the volume of a triangular prism is the same as a rectangular prism. It's the capital B times the H. Now the capital B, again, is the area of the base. So in a triangular prism, the base is triangular. So if you want, you could look at it and say the volume is 1/2 base times height. That's going to give you the area of the triangular base, and then you have to multiply it by the height of the entire shape. Now, we've been using the base times height divided by 2 formula. They're the same. Multiplying a number by 1/2 and dividing it by 2 gives you the same thing. I like this one a little bit better. I think it's slightly easier. But we're going to then, once we find the area of that base, multiply it by the height of this shape. So as I look here, this height is the height of that 2-dimensional base. This would be the height of the entire 3-dimensional shape. Okay, so I know it's kind of confusing because we're using 2 different h's, but they don't mean the same thing. Okay, so let's look at that in example number 2. So in example number 2 here, we have our base shape, which our base shape right here is a triangle. So we're going to find the area of that triangle, and then we'd multiply it by the height of this 3-dimensional shape, which is 10. All right, so let's go ahead and let's start off, and I'm going to write down the formula, capital B, H. So I'm going to start off by finding the area of the base, which is going to be 7 times 5. Remember, the base and the height of that triangle always meet at the 90-degree angle. So we have 5 times 7, and we're going to divide that by 2. And then we have to multiply that whole thing by the overall height. So the height of this triangular prism is a 10. Okay? So I'm going to start off, I'm going to do 5 times 7, which is 35. I'm going to divide that by 2. And then I'm going to times that by 10. So 35 divided by 2 is going to give me 17.5 times 10. And then if I multiply those, I'm going to totally cheat. I'm just going to move my decimal one time, and I'd get 175. So you can see I did the same thing that they did here, got the same answer. I still got 175, but I just did it a little different. So I didn't multiply by 1/2, I just divided it by 2, but you're going to get the same thing either way you do that. Okay? When you're done, make sure you label it. So in this case, our measurement was feet to the 3rd power. Because remember, our goal here was to figure out how many 1 foot by 1 foot cubes, 1 foot by 1 foot by 1 foot cubes, would it take to fill this triangular prism. Okay? All right, so at this point, guys, I want you to complete your whisk so I know you watched the video, and we will talk about this tomorrow. So make sure you come to class with questions on how to find the volume of triangulars and rectangular prisms.